In this video, we're going to talk about more examples involving integration and relating the integral to the inverse trigonometric functions. So, the first one will be the integral of 2x divided by x squared square root x to the fourth minus 1 dx. Okay, so we can write this as 2x divided by x squared and then x squared squared minus 1 dx. Okay, so obviously you're going to use the u substitution x squared because you can relate this denominator to the arcsecant function. Okay, so the du is equal to 2x dx, and dx is equal to du divided by 2x, right? So now we're going to keep the top as 2x and then express the u. So u is equal to x squared, but since x squared can only be positive, we can just put the u inside the absolute value, and that's exactly lining up well with the arcsecant that we're going to relate this to. So we're going to have u squared minus 1 inside the integral, and then the dx is equal to du divided by 2x, right? Du over 2x. So the 2x's, they get canceled, so we have 1 over absolute value u square root u squared minus 1 du, and that's exactly what we want, and that will give us arcsecant of u plus a constant. Substituting back to x, because we started with the x variable, we get arcsecant of x squared, right? Because u is equal to x squared plus a constant. Okay, the next example is a little bit more complicated, because here it's not going to be obvious. You're going to relate this to arctangent, but as you see, for the arctangent you need to have a 1 instead of a 4 here. Okay, so we're going to first divide everything by 4, the numerator and denominator by 4, right? We're going to multiply basically the numerator and denominator by 1 over 4. So we're going to get 2 over 4, okay, multiplied by 4 over, divided by 4 over 4 plus x squared over 4 dx. So that will give us 1/2 divided by 1 plus x squared over 4 dx. So we're going to take that 1/2 out because it's multiplied to the numerator. So we're going to have 1/2 integral 1 over 1 plus x squared over 4 dx. So now notice that you might say, wait a second, but the x squared is squared, but there's a 4. Well, note that you can rewrite this as 1/2 multiplied by 1 over 1 plus x over 2 squared dx, right? Okay, so if you use the u substitution, you will say that u is equal to x over 2, right? And then the du will be equal to 1/2 dx, and dx will be equal to 2 du. So as a result, you will have 1/2 integral 1 over 1 plus u squared, and then the dx is equal to 2 du. So the 2's get canceled out, right? Because the half times 1/2 times 2 is just 1. So you're basically having 1 over 1 plus u squared, and that's exactly what we want. So we get arctangent of u plus a constant. But substituting back to x, remember, we have to have arctangent of, what is u? X over 2, right? So x over 2 plus a constant. There goes your antiderivative. Now the third example is going to involve the exponential, and the integrand will be e to the x divided by square root 1 minus e to the 2x dx. So notice now that you can rewrite this as this: e to the x divided by the square root of 1 minus e to the x squared dx, right? Because e to the x squared is precisely e to the 2x. Okay, so u is going to be e to the x, du is going to be the same thing, e to the x dx. So the dx is equal to du divided by the e to the x. Okay, so now we're going to have e to the x divided by 1 minus u squared, right? Dx is equal to du over e to the x. So the e to the x gets canceled. So we're having basically 1 over 1 minus u squared du. And that's precisely the arc. You can relate this to the arc sine now, right? Because the integral of this will be arc sine of u plus a constant. Now substituting the u with the x again, back to x, we will get arc sine of e to the x, right? E to the x plus a constant. So there goes your antiderivative. I hope you enjoyed this tutorial. Please subscribe to my channel and I'll see you in my next video.